Okay, hello student. So in this second video, I'm going to go through with you 3.2, which is your additions of probability. And actually, if you follow your textbook, okay, your textbook subtopic is not only about the addition of probability, you will also learn something what we call the mutually exclusive event. Okay, mutually exclusive event. So this mutually exclusive event, if you look at the word exclusive, meaning that when you have a two set in a universal set like A and B, right? When the two set they are not intersect with each other, meaning that there is no intersection at all, then we say that the two set are mutually exclusive, meaning that the two events are mutually exclusive. Okay, so I'm going to go through one example. I will use the example to let you understand what is the meaning of mutually exclusive. Then after that, we will also define uh, the additions of probabilities. I mean the formula. Okay, so let's look at this example. Okay, two fake coins are tossed. Okay, so two fake coin. So meaning that basically you have uh two coin. So each coin will have head and tail. So remember your tree diagram. So, and then for the second coin, you also have the same outcome, which is head, tail, head, tail. You can't really see. Okay, then after that, you will have, if you toss the two coins at the same time, so the possible outcomes that you will get is SH, HT, TH, and also TT. Okay, so now these are the possible outcome. Okay, all these are possible outcome. So let's look at the first part. It says that the A is actually the event that there are two heads, meaning that you want to get two heads. And then for event B, you want to get one head, one tail. And then for event C, you want to get at least one tail, meaning that it can be one or two. Okay, so they ask you to list the outcomes of the event A, B, and C. So when they ask you to list outcome, then you have to write in the form of set. Okay, so if you look at the tree diagram that we have drawn just now, which is this one, you will notice that out of the four possible outcomes, there is only one which fulfill the event A, which is two head. Okay, so two head meaning that you will have one result, H, H. That's it. You just have one element. Okay, so in that case, this will be the elements for A or the outcomes for the event A. Then for event B, you say that the B be the event that there is one head and one tail, meaning that one head, one tail, if you look at your possible outcomes, there are two. Okay, because you have HT and TH. As I told you in the previous video, the sequence is very important. Even though the HT and TH, they have exactly the same result, like one head, one tail, but the problem is the sequence of uh, the outcomes is different, so we consider them as two different outcomes. Okay, you cannot make them as one. So meaning that for B, we have two different outcomes, which is either HT or even TH. Okay, and then for C, if you look at the question C, it says that the event that there is at least one head. At least one head meaning that it can have one head, one tail, or even two head. Okay, or even two head. So meaning that for this one, you have one head, one tail, meaning that a HT or even TH, and at least, so meaning that the two head also accepted, so the HH. Okay, so these are the outcomes for the three events. And then now for B, question B1, it says that are event A and B mutually exclusive? So as I told you before, mutually exclusive meaning that if you have two set, okay, if you have two set and you draw a Venn diagram, set A and set B, they are not intersect or overlapping with each other, meaning that these two, they share the different outcomes, meaning that they have totally different elements. Okay, so that is called mutually exclusive. But if you look at the outcomes A and B here, A, you have the HH, but B, you have HT and TH. If you look at these two sets, there is no common element, right? No common element. So we say that the A and B are mutually exclusive. Yes, they are. Why? Because they don't have the common element. But next, if you look at B2, B2 is A and C. So A and C mean this one and, sorry, hey, what happened? And also C. So you will notice that there is one common element. Okay, there is one common element. Let me use a different color. So you have one common element H and also the H here. So what I will do is uh you need to say that these two, they are not mutually exclusive. Okay, no, why? Because there is one common element HH. Okay, now then after that in question C, we are going to determine the probabilities of different event. So let's say the C I write here. So the first question, the probability of event A. So the probability of event A, meaning that if you look at your A just now, you only listed one element, right? So one element, that means the one will be the numerator. And then out of how many possible outcomes, if you look at your tree diagram, there are 4 possible outcomes. Okay, there are 4 possible outcomes, which is here. Okay, so meaning that you should write 1 out of 4. Okay, the first one. Then after that, for number 2, PB, the probability of event B, you have 2 outcomes, right? So it's 2 over 4. And eventually, when you simplify, you actually get 1 over 2, which is half lah. Then after that, the probability of C, you will get 3 outcomes. And out of the 4 possible outcomes, so it's 3 over 4. So we already have the probability of A, probability of B, and probability of C. Then now number 4, we look at the probability of A or B. Remember, this word or, meaning that is union. Union meaning that as long as the element is in A, you have to count it. And if in B also, you have to count it. Meaning that you have to take all the outcomes from 2 sets. Okay, so if you look at the A and B just now, A, you have one element, correct? And B, you have another 2 elements. So we say that there are total, if we put A or B, if we use the word or, meaning that both has to be included, means all the outcome has to be counted. So meaning that there are altogether 3 outcomes. And out of the possible outcomes is 4, right? So it's 3 over 4. And then question 5, which is the probability of A or C. Okay, if you look at A or C, yeah, meaning that if you look at the A or C, which is the first line and the third line, this one and this one, you will notice that there is one common element, right? So that means this one common element, we counted it as 1. Because if you put A or C, meaning that we have to take the possible outcomes from A and also the possible outcomes from C. But then there is one common element. So the common element, you don't need to count them as 2 times. You just count it as 1 time. So basically, there are 3 types of outcome, which is HH, HT, and TH, meaning that it's the same, which is 3 outcome. Out of the total is 4. Okay, out of the total is 4. So this one is 3 over 4, the same thing. Then after that, you have the fifth one. Okay, the fifth one. The probability of A and B. Okay, now this one is N. And meaning that is the intersection. Intersection, you remember from the topic in set 1? In the topic 1, when we say intersect, meaning that you only find the common element. So if you look at the A and B, do you think there is any common element here? The A is HH, and then B you have HT and TH. And obviously they have no common element, right? So in this case, meaning that there is no result. No result means zero, zero possibility. You can't get it. You can't get a common element between the A and B. So that's why it's 0. And then next one, question VII, or the next question, number 7. So you have the probability of A and C. Now we look at A and C, mean A intersect C. So if you look at A intersect C, there is one common element, right? So at least you have one outcome because of the word and meaning that outcome must be belongs to A and C at the same time. So you have to find the common one. So there is one which is HH, out of the total is 4. Okay, now I want you to have a look. If you look at A or B, right? Because just now A and B, they are mutually exclusive. So now we look at A or B, this one. We look at this probability. So for this P, A, or B, you actually get 3 over 4. And if you look at your A and B individually, which is these two, 1 and 2, you actually, when you go and plus the PA plus the PB together, which is 1 over 4 plus 2 over 4, you actually get 3 over 4, which is equal to this one. Okay, so this is the first formula about the probability, which is the addition law. Okay, when can you add the two probability together is when your A and B are mutually exclusive. Mutually exclusive means the A and B, they don't have the common element. So when I want to find the probability of either A or B happen, right? Meaning that you have to consider both. So you can just plus the probability, their individual probability together to get the total. So that's mean I get a conclusion is that P, A, or B, or the P, A union B is always equal to P, A plus P, B. Okay, the condition is that if your A and B are mutually exclusive. Okay, if they are not related at all, means they don't share any common element, then you can plus like this straight away if you want to find the probability of either A or B to happen. Now, let's look at the other one, which is the A or C. So A or C, you can't do that. Why A or C you cannot plus at the same time? You cannot plus straight away because your A and C, there is one common element. Okay, there is one common element. So if you do PA plus PC, let's see what happened. PA plus PC is 1 over 4 plus 3 over 4. You actually get 1, you know? You actually get 1. But the problem is that if I look at your P, A, or C, it's actually 3 over 4 only. Why is 3 over 4 only? Because, as what I mentioned to you, there is one common element. Okay, so basically, if let's say your A and C, they are not mutually exclusive, if they are not mutually exclusive, what you are supposed to do is you should do PA plus PC minus the PA intersect C. What does it mean? Because your A just now is 1 over 4 plus 3 over 4. This is your C. There are 3 outcomes, so the C is here. Okay, this one. So 1 over 4 plus 3 over 4. And then you have to minus the one that is intersect, which is A and C. And it is 1 here, 1 over 4. So minus 1 over 4. So eventually what you get, 1 plus 3 is 4, 4 minus 1 is 3. So you finally get 3 over 4. Then only you will get back the answer. Okay, the answer for PA or C, which is this one. It's the same answer. Hey, what happened? Wait. So I want to make a conclusion to you. Maybe I stop share. Okay. I use a whiteboard maybe. Okay, that's mean when you have two set, okay, when you have two set, A and then B, if I draw like this, meaning that this one, the A and B, they are mutually exclusive, which means that no common element. So if there are no common element, when I ask for this probability A or B, or I use this symbol A union B, okay, then the probability will be PA plus PB straight away. Because you just need to see there are how many elements in A out of the total plus how many elements in B out of the total. Okay, that will be the one for mutually exclusive, which is the addition. But in another case, sorry, not cases, if you have A and B, somehow they intersect partially, there's some intersection, right? Meaning that your A and B, they are not mutually exclusive. So difficult to write, exclusive. Which means that there is some common element, okay? There is some common element. When there is some common element, then your PA or B, or even PA union B, they are not equal to PA plus PB. You cannot straight away plus. Why you cannot straight away plus is because there is a certain common element. So what happened to you? What you need to do is you need to do PA plus PB and then minus the PA intersect B. You need to find out there are how many intersections are there, the probability for the intersection. You have to minus that so that you get the correct answer for PA plus PB for the A union B if they are not mutually exclusive. Okay, if they are not mutually exclusive. So this is the conclusion from the explanation just now. Okay, now I will go back to the module. Okay, let's look at your module, this page. Okay, I will straight away go to the probability, the what we call the characteristic. So as you can see from here, the two event A and B are mutually exclusive. If your A intersect B, there's no intersection, means it's an empty set. So remember, this symbol means empty set. Then after that, if your A and B are mutually exclusive, then you can straight away plus. Okay, if your A and B are mutually exclusive, then the A and B means the A intersect B should be equal to empty set. I mean nothing at all if they are mutually exclusive. Means they are totally separated, means there is no common element. Then your A intersect B should be equal to an empty set. Okay, let's look at the question straight away. What example 3? In a chess tournament, okay, the probability that the players Sam and Tim will win are 0.15 and 0.28. As you can see, these are two different persons. So the probability for him to win is 0.18, and the chance for him to win is slightly higher, which is 0.28. And you have to know that these two persons, they are not intersection of each other because they are two different persons. Okay, they do not share any, meaning that these two persons, they are totally mutually exclusive. So if I want to find the probability that the either Sam or Tim will win the tournament, so the keyword here is or. Okay, or. So what can you do is, let's say your event A is Sam will win. So then the probability of A for the Sam will win is 0.15, right? Okay, and then for B, for the event B is Team will win. So the probability of B to happen is only 0.28. So these are the information given to you in the question. And then if the first question is asking for either Sam or Tim will win, right? Either Sam or Tim will win. That's mean if I want to write in the form of the probability notation, I should start writing P and then or, meaning that you have to put A union B. That's mean either one will win. That's mean you have to include both. Okay, so that's mean for this one, because this question these two persons are mutually exclusive, meaning they are not affecting each other. There is no common element. So this one, we can straight away use the formula PA plus PB. So the A is the probability of same will win, and the PB is the probability of team will win. So you just plug in the formula, plug in the values, which is 0.15 plus 0.28. So eventually you get 0.43. So this will be the answer for the first one. Okay, and then for B, neither same nor team will win. And this one, if I want to write in the form of set, you will need the complement, because just now in the previous question, you are finding the probability that either one will win, either same or team will win. So it's A union B. But this one is none of them. Means two of them are totally cannot win. Which means that what you are supposed to find is, you should find the P A union B complement. You are supposed to get this one, P A union B complement. And this is actually the same as 1 minus probability of A union B. Why I use this one? Because once you have the complement, right, meaning that you need to use 1, the total probability, minus the possibility or the probability of the two person will win. Either one will win. So you have to minus that because of the complement. Okay, because of the complement, this one. So 1 minus, so the PA union B is actually coming from the previous question. So it's 0.43. And finally, you get 0.57. Okay, 0.57. This one, the complement, is just like if your A, you say the same win. Let's see, if I ask for the A dot, it will be, if your PA is 0.8, that means your A complement means that the same will lose. Same will lose. And then this one is win. So the PA complement will be 1 minus 0.8. Because the probability for him to win is 0.8. If you want to find the probability of Sam will not win, then you have to use the total probability minus the probability that he will win. So it's 1 minus 0.8. It's the same concept lah. Okay, it's the same concept. Now, next one, question 2. A card was drawn at the random from a pack of 52 playing cards. So the playing card, I hope you know where is that. Find the probability that the card drawn is a S or 3. Ace or 3. So let me show you the 52 playing card. So A, where is your A? Your A is actually here, This is your A. And then 3 is here. This is all 3. I mean with the different types of symbol. Like this one is the clover. Oh, I don't know. Maybe other names. And the diamond shape, then the heart shape. Then after that, got the tree shape. Okay? So, you see, if I choose the first question is asking for an S or 3. As you can see from here, if you look at the list of cards here, the A's and 3's, they are totally separated. Meaning that these two events, they are actually, how to say? They are mutually exclusive based on the conditions here. Okay, because you want to get an S, or a number 3. So S is this one. And then 3 is another 4 card. And that means they don't share the same card. When they don't share the same card, meaning that they are mutually exclusive. So if they are mutually exclusive, when I want to find the probability of getting an S or a 3, then you can just straight away plus the two probability together. So that means here, if you look at this one, out of the 52 playing cards, out of the total 52, you will 4 A's card. and you have 4 threes card. So what does it mean? Meaning that the probability of getting an ace is actually 4 out of 52. This is what you will get. Why? Because there are 4 cards with ace, and then same to the probability of getting a 3. You also get 4 over 52 because there are 4 cards with the digit 3 there. And I already mentioned to you, since these two events, they are mutually exclusive, mean they don't have any common element. So I say that this one, when I write like this, the probability of an S or a 3 will be equal to the probability of an S plus the probability of a 3. And then you just put them together, so you will get 4 over 52 plus 4 over 52. And some more, there is no intersection and no common element, so this will be the final answer. So it's a 8 over 52, and then you can simplify from there. So you actually get how much? Divide by 4. So 4 times 2 is 8, and then 4 times 4 times 3. So it's 2 over 13. Okay, 2 over 13. So this is the answer for the first one. Then now, let's look at the ace and a red card. Okay, the second example, ace and the red card. And you need to check first whether they are mutually exclusive or not. So let's go back to the playing card. You want the ace and the red card, right? So let's erase this. Okay, so where is your ace? Again, your ace is actually not clear. I use this one. Okay, it's actually this part, all ace. And then your red card is actually here, you know, the 2 row in the middle. Okay, the 2 row in the middle, which means that for the red card and for the ace, there are 4 cards. And for the red cards, how many red cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is 26, meaning that there are 26 cards with the red color. Okay, mean with the red color symbol. And I want you to pay attention to this part. You will notice that there is some overlapping. How many is overlapping? 2 of them. Why? Because you will have 2 cards showing ace and it is a red card at the same time, meaning that you have 2 red cards showing ace. Okay, showing ace. So in this case, when I ask for the probability of an ace or a red card, you cannot straight away plus them. Okay, you have to minus the one in common. How many commons are there? So in this case, there are 2 common. Okay, there are 2 common, 1 and also 2. Remember, 2 common. Okay, let's go back to the question. So how you should write the answer. So just now the probability of getting an S out of 52, there are 4 cards, right? So this one no change. And the probability of getting a red card just now is 26, right? Is it 26? Yeah, 26 out of 52. So these are the 2 things that you have already obtained. Then after that, I also want to check with you how many intersection. Sorry, on my battery. Okay. Another one is how many the intersection. An ace and is a red card. Eh. So just now I already told you there are 2 of them. So it's 2 over 52. So in this case, when I want to find a probability of an ace or a red card, the probability of an ace or red card, it will be the probability of the ace plus the probability of red card minus the probability of ace and red at the same time. So what is your PS? is 4 over 52. How many red cards are there? 26. So 26 over 52. And then minus, there are 2 in common. Okay, so eventually what do you get? So 4 plus 26 is 30. 30 minus 2 is 20. 28. So 28 over 52. And then you can divide by 4, I think. So 4 times 7, 28. And then 4 times 13, you get 52. So this will be your final answer for the second one. So I want to repeat to you, when it is mutually exclusive, then you can straight away plus the two probability together. If they are not mutually exclusive, you can plus, but you have to minus their intersection. How many intersections are there? Okay, how many intersections are there? So I think that's all for today. And your homework, you don't need to do the textbook exercise first. You just want you to do the next 2 page, which is try yourself 1 and also try yourself 2. And I'm going to go through this answer on either Monday or Tuesday. Okay, depends on your next lesson. Okay, so I think that's all from me. Thank you. Bye-bye.